Hello everyone. Today we're going to start the process of designing new rods and valve gear for my 1-inch Pacific, modeled after a Southern Pacific P4 Class 462, road number 2414. First, a little history about myself and how I ended up with this locomotive. I have a soft spot for 1-inch little engine Pacifics because that's how I got started in this hobby. In 2009, while in college at the Eastman School of Music in Rochester, New York, I met a group of troublemakers at the Rochester Institute of Technology that were members at the Finger Lakes Live Steamers. After the snow melted, they took me to check it out and we ran our little Gauge 1 steam engines. But after walking around the 1-inch railroad, I was hooked and simply had to get a ride-on steam locomotive. That summer, a 1-inch Pacific came up on Discover Live Steam, and I worked all summer to pay back my parents for fronting the money. If I remember correctly, it was completed in 1991 by John Saravino from the Sacramento area. I ran it that summer at Golden Gate Live Steamers and took it back to Rochester where I ran it every opportunity I could on the weekends at Finger Lakes Live Steamers. A few days before coming back home to California in 2013, the engine had a needle bearing failure on one of the driving axles. I guess I literally ran the wheels off it. I knew I wouldn't have the equipment or connections to get it fixed, so I sold it before I left, and it's still at Finger Lakes to this day. After settling back into California, I became acquainted with the live steam community on the West Coast, and eventually met Bill Peter, the man behind PBL brass model trains. When I met him, he had this beautiful 1-inch little engine Pacific sitting in his garage. He had seen it years before at Golden Gate Live Steamers and had to have it, and the timing was just right that he was able to buy it. When I saw it, I wanted it bad, but he understandably didn't want to sell it. Then occasionally he'd be in the mood to sell it, and I didn't have the money, and it went back and forth this way for a couple years until the stars finally aligned, and I brought it home in 2017. It was built by Euler B. Smith of the Golden Gate Live Steamers, and to my knowledge I'm the 4th owner, although it has had other caretakers between owners. It's a great runner and it shows, so it's in need of some tender loving care. One of these days I'll get around to a complete teardown to refresh the cosmetic condition and the piping, but for now I think a new set of rods and valve gear will go a long way. Other than wear, there's nothing wrong with the existing rods, but when compared to a picture of the real thing, something just doesn't quite look right. And for my taste, rods can really make or break the look of a locomotive, so I'd like to give this engine some new legs. We'll start by accurately measuring the existing rods, just in case they're slightly different than the blueprints. I want to measure the distance between bearing centers as accurately as possible. Normally I would do this on the CNC mill where it's very easy to adjust the table in small increments, but it was cutting a mold at the time. By clearing the DRO on the bearing center and then finding the other, I'll get a pretty good measurement on the distance between centers. Since the rods are castings, I won't get a perfect center distance from hole to hole. There will be a small offset on the y-axis, but with some simple geometry I can calculate the actual length of the rod from these two numbers. The mirror goes a long way to see the indicator when it's facing away from me. I do have a coaxial indicator that would be great for easily finding center, but the one I have isn't very good, and I know I can trust this indicator to get me within 1/10 or 2 of center, depending on how long I'm willing to fuss with the dials. Lastly, we'll measure the main rod. We don't really need to, but I want to double check to make sure it's not too far off from the print. If I make a new one to print and it's, say, 1/8 inch shorter or longer, that could cause the piston to bind against the cylinder heads. Anything more than maybe 10/1000ths of an inch should probably be taken into account. So here are the measurements I recorded. After measuring the rods from the other side, these are the axle distances. A little off from the prints, but not by much. The engine turns nicely with no binding, so the new rods will be made to the old dimensions. Unfortunately, I don't have prototype drawings for the SP Pacific rods, but I'll be using photographs from the Denver Public Library as a reference to get the proportions about right. If you're not familiar with the Denver Public Library's digital collection, you are missing out. They have tens of thousands of railroad photographs, many of which are very high resolution. Their collection spans a wide range of railroads and eras, and with their consistent naming system, it's very easy to find out what you're looking for. This isn't an ad, I'm just very appreciative of the incredible resource that they've made available for free. Be sure to check it out in the link below. I have the Little Engine's 1-inch Pacific drawings for the rods and valve gear, so I will reference those to know where my limits are for rod thicknesses and offsets. I'll point out some notable things about how I draw out rods and some design points, but this won't be a full-blown tutorial, so don't blink. So I like to draw side rods in as few steps as possible. I usually start from the side, and I use a lot of construction lines. They help to keep things symmetrical and centered. We'll start with the rod end diameters, then draw in the bearing hub diameters. And drawing the flat lands where the oil cups will screw in. I've said it before and I'll say it again, the fastest way to draw in SOLIDWORKS is just to put the lines down that you know you're going to need. Don't worry about whether or not they're in the right place or the right size, just get them on there and then put in your geometric relationships and dimensions later, and it'll all come together very nicely and very quickly. So now we're doing the flats on the other side of the rod, bringing that geometry over. And once you've drawn something once, if you have to draw another feature that has similar shapes for similar dimensions, similar features, just copy the dimensions over. There's no use in drawing it all out again the same way and redimensioning everything. So I can take these arcs and just make them equal to the other side. And that way if I have to change it, I only have to change one dimension. Putting construction circles, the ends, will make it so that I don't lose geometric relations while I trim entities. Now we'll just put in these radii here, trim up the entities that we don't need. And it broke this here, so we'll make this arc co-radial with that construction circle. And draw the main part of our rod here, the bar that goes across. So this first profile is nearly done. Just need to extrude it. Extrude it about the mid plane. Gonna shorten that up a little bit. I'm drawing this outside the part because it's a little bit easier to see what I'm doing. And then as long as you don't dimension anything, once you snap it to the edge of the part, it'll transfer over without distorting. Setting how far the relief is from the ends. So this will be the profile of the rod from the top. It has a little bit of a relief on the sides. I'm drawing a construction line down the middle so I can mirror the profile. And now we're creating the little piece that will connect to the other side of the rod. I should have done this a little differently. I'll edit it later. Rather than using 2 dimensions to center up that middle web, I should have just made the 2 lines equal so that I only needed to put in 1 dimension. But I'll fix that later because it'll become a problem in a little bit. Make that larger because it needs to have a bushing. Now we just need to put in the flutes. Some of these dimensions I'm using, I just know from having drawn so many rods before, the radius on the inside of the flutes is usually 6 inches on the prototype, so in 1-inch scale that would be 1/2 inch. Draw another construction line down the middle so I can mirror that profile. And extrude cut mid-plane. Add our fillets. And this rod's pretty much done. So now we can move on to the front rod. I don't usually like to draw 2 parts in the same part file, but if it's something I'm doing for myself, for my own personal projects, it's a little bit easier. So we'll go ahead and draw this rod in the same part file. Setting the length that we measured from the actual rod. Again, I'm snapping this to the existing geometry on the other rod. That way, if I wanted to go back and change any of these fillet radii, I could just go back and change it on the original part, and everything will change with it. If you dimension out everything individually, then you'll have to go back if you wanted to change it and change everything all over again. So I'm drawing a circle here. I'll use this to drive the diameter of the rod end for the front side rod. Now we'll draw our fillets and extend across the middle bar, I guess I'll call it. Adjust that diameter. Put in our fillets. Okay, now we extrude about mid-plane. We need to go a little thicker on this one for the knuckle joint. That construction line down the middle is very helpful. I pretty much have that on every single sketch throughout this whole process. We'll tuck this into a nice spot. A lot of rods have little extra clearance right at the mouth of that fork. So I'm kind of just making this to whatever looks good. Five degrees per side looks pretty good. And we'll continue drawing the rest of the profile from the top view. Not too much to say here, we'll just finish drawing the profile. Okay, we have our profile there. I think this doesn't look quite right. I'm going to change some of these dimensions just a little bit. Make this a little thicker. Here's where I have to change that so that the lines are equal. Broke my taper there. I have to just readjust that. And now it looks kind of too thick. I think I might thin it up just a little bit more. Kind of go right in the middle of where it was. And I like that. Now we just need to cut our flutes on this rod. And I can grab the geometry from the other rod as well, so that I don't have to re-input all those dimensions again. Just make the line collinear and the fillets equal. Draw our center line and mirror the sketch, and extrude about mid-plane. Put in our fillets. We're going 15 thousandths on the outside. And that rod is done. Now I want to draw in the knuckle pin. It'll be good to have it planned out ahead of time. And I like to make it square on the back to sort of key it in place. You'll see in a minute how this will work. On the full size, they were keyed on the back, but that's pretty annoying to do on such a small part. So by making the back of the pin square, it'll key itself in. So we'll do a revolve feature to draw the actual pin here. So the pin itself will come up against the shoulder on the inside of the fork. So with the revolve, we only need to draw half of the pin. The construction line helps with that, so we can still define it by the diameters. There'll be a washer and nut to squeeze it in place. So it'll only be tightened on one side. You won't risk collapsing it when you tighten the nut. And then the back of this pin will have a matching score on it. And I like to draw the clearance in there, so I'm drawing in 1/1000th of clearance. To make it a little easier when I go to program it later. I won't have to offset it. I can just program it to the part. Since this will be made from round stock, instead of chamfering the corners, I'll just make it round, part of a circle. So now we'll start on the main rod. This will be pretty much the same process, but the main rod's a little bit more complicated. I'll still draw a circle to represent the main crank bearing, just as a construction circle. I'm actually referencing a drawing I have for the Southern Pacific 060 switchers. The main rod looks very close on the switcher to what I see in the photographs, so between that and the pictures we can get it pretty close here. Putting a center point on the arc on the back of the rod is a good way to give yourself a point that you can dimension it to. The main rod also has these flats for oil cups. And once again, construction lines are your friend. Here's another example of where just throwing on the geometry approximately where it's going to go, but putting on the arcs where I want them, making them tangent, and then putting some dimensions on them is much easier than trying to draw each line correctly as you go. So once I put in all these relationships, then as I start putting in dimensions, everything will kind of fall into place. Now that's fully defined. Extend these lines out. And we're nearly done with the first profile in the main rod. We'll draw in just make a couple dimensional adjustments. And we'll extrude it about mid-plane. Now we'll cut our top profile in. This is going to be a little bit different because the end of the rod is skinnier than the crank pin end of the rod. But otherwise it's mostly the same process. I got my construction line down the middle so that when I finish drawing the profile on one side, I can just mirror it. The other nice thing about the construction line is you can dimension the full width of the part off of the construction line. You don't have to worry about dividing by 2, even though you're only drawing half the profile. So now we'll do our flutes, same way as before. We're going with an 1/8 inch web in between the flutes. I think it's supposed to be less than that to be truly to scale, but 1/8 inch is a reasonable compromise. Mirror that. And we'll extrude that cut and fill it till our heart's content. We're going with a 50 thousandths fillet because I'm going to use a 3/32 ball end mill to cut in these flutes. That gives me a little extra room so that I'm not taking a full cut on the ball end mill. Okay, now we have to cut the slot that our bearing's going to go into. The bearing on this is going to be just like the prototype. It'll slide in from the outside and get pushed into the back of the rod and held firmly in place with the wedge. I had considered making a dummy bearing, just machining it all in as one piece so that it had the cosmetic appearance of having the bearing there, but it would actually be a lot of material removal, and I decided it would maybe actually be easier just to make the wedge and make an individual bearing and just make it like the prototype. It's more parts but less of a headache to machine it that way. So now we'll draw the bearing. And again, we're drawing multiple bodies in the same part. The bearing will be a separate entity, so very important to remember when you're doing multiple parts in a single part file that when you start making the second part and you go to extrude it for the first time, you want to make sure that you have merge result turned off. Otherwise, everything will combine together and you'll end up with a single body, which is not what you want, because you want to be able to separate the bodies later to make drawings or to separate the models out to program off of if you're using CNC. Now we're cutting the relief in the middle where it's going to have clearance to fit inside the slot. Put our fillets on here, make it look pretty. And now on the back side of the bearing, we have to cut out our reliefs so that it can actually slide in and be locked in place when it's up against the back. So this geometry will almost match identically the inside slot in the main rod, although it will have some clearance so that it fits in. I'm again putting in about 1/1000th of clearance for a combined total of 2/1000ths clearance. So we'll extrude cut this just in one direction, so we only want to cut one side of that bearing, and that's what it'll look like. So now we want to draw on the wedge. 4 degrees works here. And when I go to program this, these parts will all get separated out into separate step files before I move them over to Fusion 360. So it's very important for each one of these not to merge bodies. This is a little piece that will have a 440 thread going through it to put pressure against the wedge. I don't usually use the whole feature, but sometimes it's handy. And that's pretty much it. So, admittedly off camera, I drew a new crosshead for the engine using the Southern Pacific 060 drawings as well. The dimensions matched very, very closely, so I just used that. And did a little bit more work on the rods off screen, drew the oil cups, and in the next video we'll start machining them. So, if you want to see that, be sure to like and subscribe, and turn on notifications so that you don't miss any installments from this series. Thanks for watching.